Good morning. In the previous classes, we have discussed what is instantaneous center, combined motion of rotation and translation, or general plane motion, can be represented as motion of pure rotation about some imaginary center. And that center of rotation, which changes from one instant to other instant, is called the instantaneous center. So, we have discussed in the examples. First one is the motion of the wheel of a car rolling without slipping, motion of a sphere rolling without slipping, then the motion of links in a machine. One last example shown there was motion of connecting rod and piston of a reciprocating engine. Let us see. This is paired links. See, in the automobiles, you can see inside the engine there will be a crank like this. This crank will rotate. This is called the crank pin. So this AB is called the crank pin. This is the crank, and the wheel will be attached to this through an axle. The wheel will be outside in concentric circle with respect to A as center. So the wheel will be connected to the crank through a axle, and this is the connecting. This is the crank pin. We call it crank pin. This crank rotates with a constant angular velocity omega radians per second. Now here, this end there will be a piston. Inside the piston there will be a piston rod. So this will start from here and this will move to and fro. The piston will be moving to and fro. Okay, and the piston and the crank pin will be connected to the piston through a connecting rod. So this is the connecting rod. CB is the connecting rod. One end is connected to the piston. So this end of the connecting rod will be having to and fro motion because the piston moves to and fro. The other end of the connecting rod is connected to the crank pin, which will rotate. So this end, at the end B, it is having motion of rotation. And at the end C, it is having translation, horizontal displacement. So if you view the motion of this connecting rod, it is combined motion of rotation and translation. So that is an example we have discussed in the first video. So motion of connecting rod and piston in a reciprocating engine. So this is the mechanism. Now, normally the question will be, you'll be given the radius of this crank pin at a certain instance. So it starts from here. See, in this one, I'll show it slightly enlarged. Initial position of this AB will be like this. It will be in this horizontal position. When the crank is in this position, or the crank pin is in this position, this point F is called the inner dead center. When this crank pin is in this position, this piston will be at this extreme. The piston will be here at this end. And as the piston moves, as the piston having a forward stroke, as the piston moves forward, as such, the crank will rotate. Or as the crank rotates, the piston moves forward. And for one forward stroke, when it reaches this end, the crank from here, it will rotate, this crank pin will rotate and it will come to this position. This will be the position of the crank pin. And then when the crank rotates like this from here to here, the piston will move from in the reverse direction. It will move from here to here. So one full rotation of the crank is equal to 2 strokes of the piston. 2 stroke is STROKE. So from here to here, 1 stroke. So during that time, the crank pin will rotate from F to this position. Then from in the reverse stroke of the piston, the crank pin will rotate from here to here. Okay, so the combined motion of rotation and translation of this connecting rod, you will be given certain data and you may be asked to find out what is the velocity of this end of the connecting rod, what the velocity of the piston. You may be asked to find out what is the angular velocity of this connecting rod, etc. So let us see how to solve this examples. So in the figure, AB is the crank. The radius of the crank is R. radius is r. So radius of the circle. This is the radius of the crank pin. It rotates about a with uniform angular velocity omega radians per second. The crank rotates at a very high speed, so that normally the speed of the crank will be given in revolutions per minute, rpm. So n revolutions per minute, the crank rotates n rpm. So we have to convert it into 2 pi n by 60 radians per second. N is the number of revolutions of the crank in rpm. And BC is the connecting rod of length L. The connecting rod, the BC is the connecting rod. The length of the connecting rod is L. C, the piston. So this is the piston whose to and fro motion is governed by the connecting rod. When the crank completes one rotation, the piston completes two strokes. So these are the things which we have discussed now. Now the question is to find the velocity of the piston. So when you deal with combined motion of rotation and translation, what we do? First of all, we locate the instantaneous center. So velocity of the piston is horizontal in this direction VC. Draw a line normal to that. So this is the line drawn normal to that. This is the normal line. Normal to VC. That is a perpendicular line from here. This at right angles to VC. Now, this end of the connecting rod, it is having a motion of rotation. So suppose at a particular instant, the crank has rotated through an angle theta from the inner dead center. This is the horizontal line extending of the direction of velocity of C. This end is called the inner dead center. Initially, the crank pin will be here. It has rotated through an angle theta. So this end of the connecting rod B will be having a velocity, linear velocity, V is equal to R omega. So VB will be R into omega. So we know the direction of velocity of this end, the direction as well as magnitude of velocity of this end. You draw a line at right angles to VC. We have drawn this perpendicular line. Draw a line at right angles to VB. At right angles to VB means you extend this radius vector. Extend this radius vector. The intersection point is called the instantaneous center. So now I can imagine with I as center, IC as radius, it is rotating. The piston is rotating. So the crank, if you take any other point B, with I as center, with IB as radius, it is rotating. So the motion of this connecting rod can be assumed to be pure rotation with I as center and an angular velocity of ohm radians per second. It rotates in anti-clockwise direction because VC is in this direction. With this as center, IB as radius, if you imagine a circle, you draw a circle like this. So this is the velocity. So first of all, locate the instantaneous center. So that is written here. Draw perpendicular direction of velocity of C, perpendicular direction of velocity of B. That is, produce the radius vector. Intersection point is the instantaneous center of rotation for the connecting rod BC. Now we have the rule, velocities are proportional to distance from instantaneous center. So VC by IC is equal to VB by IB. Distance to B from I, distance to C from I. So VC by IC is equal to VB by IB, or VC by VB equals IC by IB. From that we can get the velocity of the piston VC is equal to VB by IB into IC, where this VB is R into omega. Now our aim is to find out this IC and IB, the length, that is simply trigonometry. Use trigonometry and find out the length IC and IB. You are given the radius, you are given the length of the connecting rod L, and you will be given theta. So omega is given. So R, theta, L is known to us. So based on that, we have to find out IC and IB. So just some mathematical jugglery now we are going to do here. First of all, this angle theta, phi, I am marking this as phi. That is angle which the crank rod in this connecting rod, the connecting rod makes with the horizontal. It will be phi. If you want to find phi, see, consider this triangle. We are making some constructions here. Some construction lines are made here. That is, this connecting rod, this length is extended. This is extended to this side. And from A, I am dropping a perpendicular so that it meets at D. Line CB is extended. From A perpendicular is dropped to meet at D. Now from B, I have dropped a perpendicular to this horizontal, so it is E. Now referring to this figure, this is R, this BE will be R sine theta. This BE is R sine theta. This triangle BEC, sine phi is equal to, we can write sine phi is equal to this opposite side. This opposite side is nothing but R sine theta. Is equal to opposite side R sine theta divided by hypotenuse R sine theta by L. So R is given. Theta is the angle through which the crank has turned at a particular instant. That is will also be given. L, length of the connecting rod, will be given. So we can get what is the position of this connecting rod with respect to the horizontal. Sine phi is equal to R sine theta by L. Okay, you get that phi. Once you get phi, we can consider this triangle. Consider triangle ICA. Triangle ICA. In this angle is phi. So the remaining angle, this will be 90 minus phi. This angle is theta. So you just use trigonometrical principles and find out IC and IB. That is shown here. IC by IB, this IC by IB, we can connect it with this triangle, triangle ADB. IC is parallel to AD. This side CB and BD are same extension of one another. Similarly, IB and BA, they are extension of the same line. So these two triangles, the large triangle ICB and triangle ADB are similar triangles. So I can write IC by IB is equal to AD by AB. So if you get AD and AB, you can find out what is IC by IB. That is what is done here. So for that, AD by AB has been calculated. AD is written in terms of, refer to the figure, AD equals AC tan phi. You will get some expression. And AD by AB, AB is nothing but radius vector. So finally, after applying all the trigonometrical rules, getting the sides, you will get the velocity of C. VC is equal to omega into L sine phi plus R cos theta tan phi. So this is the equation for the velocity of the piston. Either you can't by heart the formula and use it, which is simple. But if you by heart the formula, it should be by hearted correctly. Otherwise, just use the trigonometric principles, the large triangle and the small triangle, similar triangles. From similar triangle rules, IC by IB equals AD by AB. AD and AB you can get from trigonometric rules in terms of theta and phi. Finally, you will arrive at this. So, velocity of the piston is omega into L sine phi plus R cos theta tan phi. And where this phi, we have got it in the first step itself. Sine phi equals R sine theta by L. So if you remember these two formulas, by remembering these two formulas, we can solve the example of motion of connecting rod and piston of a reciprocating engine. We don't know whether you will be getting university exam questions from this particular module, because in the previous two questions of 19 scheme, there were no questions from this particular portion. As I have mentioned, it is mentioned in the syllabus concept only, but all the questions of 2015 scheme, you will be having one definite question from this particular portion. So there's a chance that you may get from this time, because the last three questions were prepared by the same person, so who have skipped that. Maybe this time another three sets of questions will be prepared for your present examination, then supplementary examinations also. So you may get question from this particular portion. We are not sure. So don't leave this. It's a very simple one. So, question will be very direct question. By just applying this formula, you can do it. So let me illustrate one example. So we have seen the velocity of piston is given by the expression W omega into L sine phi plus R cos theta tan phi, and sine phi equals R sine theta by L. Let us have a numerical example. The crank of a reciprocating engine is rotating at 210 RPM. The length of the crank and connecting rod are 20 centimeters and 100 centimeters respectively. Find the velocity of the piston when the crank has turned through an angle of 45 degrees with the horizontal. Angular velocity of the connecting rod. Least velocity of any point in the connecting rod. Okay, let us see one by one. The crank is rotating at 210 rpm. So let us find out. Here I have drawn the figure. This is the crank, 20 centimeters radius. The piston, they are connected with the connecting rod 100 centimeters. So 20 centimeter, 100 centimeters given in the question. The velocity of the piston when crank has turned through 45. So here mark the crank at 45 degree. This theta is equal to 45 degree. So from the speed of the crank 210 rpm, let us find out the angular velocity of the crank. Omega equals 2 pi n by 60. That is the first step. Then I'll mark this horizontal line, that is the line of extended the line of the velocity of piston. The angle which the connecting rod makes, phi. Sin phi is equal to this opposite side divided by L, that is r sin theta by L. According to this expression, sin phi equals r sin theta by L. Substitute, we will get phi. Once you get phi, now we can apply this equation. VC is equal to omega L sin phi plus r cos theta tan phi. So let us apply this equation. VC is equal to omega into L sin phi plus r cos theta tan phi. Directly you will get 3.555 meter per second. If you are not able to by heart this formula, what you have to do is you start from the first principles. How will you do? We have VB, velocity of this crank, linear velocity of crank, VB equals r omega. Radius is given, omega is given. So VB we have got. Now let us apply VB by IB equal to VC by IC. So that is what you are doing here. VB by IB equals VC by IC. So ICB triangle, we are taking triangle ICB. This is the crank pin, this is the horizontal. So we have this triangle ACB also. AC is straight line, B is 1 point. So IB can be written as, what is this IB? IB is equal to IA minus AB. What is this IA? This angle is 45 degree. So let us find out. IA is equal to, let us get to each distance separately. IC, in order to get IC, we require this distance AC. If you consider triangle ICA, we need this distance AC. How will you find out that distance AC? AC is equal to L cos phi plus R sin theta. Refer here. This is AC, this total distance. This much is R cos theta. This is L, this is phi. So this is L cos phi. This much is L cos phi. L cos phi plus R cos theta. That is what is written. L cos phi plus R cos theta. L cos phi plus R cos theta. That is this distance AC. Once you get AC, IC is equal to, this angle is 45. This angle is 45 degree. So tan 45 is equal to IC by AC. From that we get IC. We'll get IC. Just trigonometrical principles. Once you get IC, then we get IB. So IC is got. You have to get IB. What about IA? In this triangle ICA, IC is known, AC is known. So we can find out IA. IA is equal to I sin 45. Sin 45 is equal to IC by IA. IC divided by IA. From that we get IA. Once you get IA, IB is nothing but IA minus AB. IA minus AB. So all these expressions we can get from solving the trigonometry. Then also you will get the same distance, same answer. So if you are difficult for you to compute from trigonometrical principles, you have to by heart that formula. VC is equal to omega into L sin phi plus R cos theta tan phi. You get the answer. Once you get the velocity of the piston, second part of the question, what is the angular velocity of connecting rod? Angular velocity equal to VC by IC. So anyway, we have to find this distance IC. This IC is required. So for finding that distance, we have to follow the steps. Okay, AC is L cos phi plus L cos theta. From that, you get IC is equal to AC tan 45. So VC by IC will give you the angular velocity of the connecting rod. That is, this is the angular velocity ohm. Or it will be VB by IB. Anyway, we have to find either the distance IC or find the distance IB. So it is better you apply the trigonometric principles and find out all the distances. Another third part of the question is, what is the least velocity of any point on the connecting rod? So if you want to find the least velocity of any point on this connecting rod, the least point will be at minimum distance from here. So drop a perpendicular from I to this connecting rod. Let it meet at X. So find out this distance Ix. Once you get ohm into Ix will be the least velocity. How to get Ix? This angle is 90 minus phi, or this angle is phi. So sine 90 minus phi is equal to Ix by Ic. Ic already we have, so find out Ix. You get Ix. Sine 90 minus phi is cos phi, so I get Ix. So Vx is equal to Ix into O. So that you will get the least velocity of any point on the connecting rod. So such questions were very common in the previous university exams of 2015 scheme. Then let us see whether we are getting such a question in this semester or not. Okay, so stop for the day. Thank you.